Hello students, today let us do this question in which it says two towns A and B are connected by a regular bus service. So the bus leaving the town in the either direction, there are two towns A and B. So there is town A and there is town B like this. And the bus is moving from A to B. Many buses are present like this. First bus, second bus, third bus, fourth bus, fifth, sixth, seventh, eighth, ninth, tenth. The buses are moving in this direction. The buses are moving in the backward direction also. Okay. So now he says all the buses are going with same constant speed v. So velocity of bus is a constant value. Okay. So uh, now all the buses are going with same constant speed v. A man cycling with velocity of the cyclist that has been given, which is equals to 20 kilometer per hour. 20 kilometer per hour is the velocity of the cyclist. Now, as the buses are moving with constant velocity, the distance between these buses would be a constant value. Okay. The distance between the buses would be same value. Even in this direction also, it will be same value. The distance between any two buses would be same value. Okay. Now, this cyclist is moving. First, we'll see condition when he's going from, when he's getting crossed by the bus, which is moving from A. In this case, he is present at fourth bus position. Okay, he's with the fourth position. The third bus is going to cross him from the behind. Okay, third bus is going to cross him from the behind. We have to check what is the scenario that has been like. What will happen in how much time it is going to cross him and all. Okay, so we will check only this part. The third bus is crossing this person. Okay, so let me take the cyclist like this. He is moving with 20 kilometer per hour, and the third bus which was present, it was already at a distance capital D. Let us assume it was already at a distance capital D from the cyclist. Okay, this is cyclist. He is moving with 20 kilometer per hour. The third bus is already present at capital D distance from that cyclist. Now what happens? This bus is coming and crossing him. Let us suppose at this position, this fellow, the cyclist will also move at some distance. He is going to, let us assume, move this much distance. Okay. They both are crossing. The third bus is crossing this cyclist at this position on the road. Okay. The third bus is crossing him at this position. Let us assume this is the distance traveled by the cyclist in that same time. Okay. So, how much is the distance traveled by the bus? Distance traveled by the bus is D plus capital D. Distance traveled by the cyclist is small d. Okay. So distance traveled by the bus is D plus capital D because it has to cross him. In that time also the cyclist is moving. So see this case we can solve in two methods. Either by relative velocity method or in the perspective of the observer present on the ground. First, I will solve in the perspective of the observer on the ground. Then we will solve it in a relative velocity concept. Both are going to give you same answers. Some students will feel like they'll get the feel, they'll understand only with the ground observer. The other students who are like much more faster, like if you are practicing for JEE or NEET, you have to use the relative velocity concept because that is much more easier concept. Okay. Same question. Now let us see. The cyclist has moved D distance. Okay. So what is the velocity of the cyclist that has been given? Velocity of the cyclist is 20 kilometer per hour. Okay. And the time taken for the bus to travel him or to cross him has been given as, how much is that? It has been given as 18 minutes. 18 minutes is the time taken for the bus to cross him. So in that time only, he will be traveling this small distance. So can I write small d distance is equals to velocity into time. Velocity is 20 kilometer per hour into time should also be taken in hour. So 18 by 60. Yes. Small d distance we'll get, which is how much? 6 3 is 18. 6 times 20. This and this gets cancelled. So it is 6 kilometers. So small d distance is 6 kilometers. In the same time, what is the velocity of the bus? Velocity of the bus is equals to distance traveled by the bus divided by time taken by the bus. Okay. So how much is the distance traveled by the bus? which is equals to d plus, in the place of small d, I can write it as 6 kilometers divided by the time taken by the bus is nothing but equal to 18 minutes. In that 18 minutes only it is traveling the same thing. So 18 by 60. This is my case one, where the bus is overtaking that cyclist from behind. I hope you understood this. So this would give me velocity of the bus is equals to d plus 6. 6 3 is 18. 6 10 60. So this 10 will go up. So d plus 6 divided by 3 into 10. Let us write it as some equation. Okay. Velocity of bus we have found out in this case. Next, we will go to case 2. In case 2, we are going to see the bus is going to travel on the other side. Now, in this, he is present at this 6. Okay. The cyclist is present at 6th bus. The 5th bus has to travel. He is present d distance from this 5th bus. The cyclist is present at d distance, capital D distance from the 5th bus. Let us now draw the same thing. The cyclist is present here. He is moving in this direction, and they both, the 5th bus is present at some capital D distance. Okay, some capital D distance. That bus is present from the cyclist. Okay. Now, this distance, let us take this cyclist velocity is 20 km per hour, and this bus is crossing him in how much time? 6 minutes has been given. The bus is crossing him in 6 minutes. In that 6 minutes, how much is the distance? Let us take, this is bus scenario, and we'll see cyclist scenario. The cyclist has traveled. Velocity of the cyclist is equals to distance traveled by the cyclist upon time taken. So velocity of the cyclist is 20 km per hour. Distance is small d. Let us assume small d distance. He has traveled some distance here. In this place they are crossing. So if this is small d, this distance would be capital D minus small d. Okay. So the bus will travel capital D minus small d. So 20 is equals to d upon time taken is equals to 6. But we have to take it in hours. So 6 by 60. 6 1 6 10. So this 10 goes up. 20 is equals to 10d, or d is equals to 2 kilometer. Okay. So this d is equals to how much? 2 kilometer. Now, let us come to the bus. How much distance the bus is traveling? D minus small d. Velocity of the bus is equals to d minus small d upon time taken, which is 6 minutes divided by 60. So d minus small d is d minus 2 divided by 1 by 10. 6 by 60 is 1 by 10. This 10 will go upwards. We are going to get velocity of bus is equals to d minus 2. This is second equation. We have got velocity of bus in both cases. Yes, velocity of bus here and velocity of bus here. Both are equal because bus is moving with a constant velocity. So can I write it as d plus? So we write this d plus 6 by 3 into 10. D plus 6 by 3 into 10 must be equal to d minus 2. D minus 2 into 10. Okay. I hope you understood this. Now what will happen? This 10 is still get cancelled. If I send this there, d plus 6 is equals to 3d minus 6. Okay. So if I send this here, 6 plus 6 is 12. 3d minus d is 2d. Sorry, this is capital D, not small d. This is the distance traveled by the bus. So 3d minus 6 is equals to 12. That is 2d. 2 ones to 6. So d, capital D is equals to 6 kilometers. The capital D is 6 kilometers. Now we can substitute in any equation to get the velocity of the bus. Let us substitute in this equation. Velocity of the bus is equals to 6 minus 2 into 10. That is nothing but 6 minus 2 is 4. 4 into 10 is 40 kilometer. 40 kilometer is the 40 kilometer per hour is the velocity of the bus. Okay. So the velocity of the bus is 40 kilometer per hour. Now we have got velocity of the bus, which is 40 kilometer. Okay. So we have got velocity of the bus, which is 40 kilometer. Velocity of the bus is equals to 40 kilometer is what we have done. Now, he is not asking velocity of bus. He is asking velocity into time. That means how much this time distance, how much time these both buses, like two buses, the distance between two buses is capital D. And for every t minutes they are moving. Okay, for every t minutes they are coming means the time they taken by the bus would be t. Okay, so for every t minutes, if it is yeah, like it is a regular service for every t minutes, the distance between these two is distance d and time taken is capital T. So we have already found out the distance of this as 6 km. Now, velocity of the bus is equals to distance upon time. Velocity of the bus we have got as 40. Distance is 6 km divided by time. The time is equals to 6 by 40. Okay. Now he's asking V into T value. V value we already know it is 40. And T value is 6 by 40. 40 and 40 gets cancelled. Okay. 6. The value of Vt is 6. The value of Vt is 6. Now let us do the same question in relative velocity function. Okay. So the cyclist is moving in this way. Case A that we are going to see. So in that, the bus is moving like this. The distance between the bus and the cyclist, the relative distance between them is d. This distance will be covered with relative velocity. So velocity of bus is there, velocity of cyclist is there. Now, can you tell me what is velocity of bus with respect to cyclist, which is velocity of bus minus velocity of cyclist. Okay, is equals to, who is the observer? Cyclist is the observer. For cyclist, the distance the bus is traveling is in positive direction. So d by the distance traveled by time. So time, which is 18 by 60. 18 by 60, right? So relative velocity is equal to distance by time, 18 by 60. 6 3 is 18, 6 10 is 60. So velocity of bus minus 20 is equals to 10d by 3. This is what we get as first equation. Next, second case scenario, where the cyclist is moving in this direction only. The bus is moving in the backward direction. Now also the distance between the cyclist and the bus is again d. Okay. And velocity in this case, velocity of bus with respect to cyclist is again velocity of bus minus velocity of cyclist. This time the bus is moving in negative direction. So that is minus Vb minus Vc is equals to relative distance. Who is the observer? Observer is the cyclist. The relative distance this bus is going to travel will be in negative direction. So that is minus distance by time taken, which is 6 by 60. Okay, that would give me minus velocity of bus minus 20 is equals to minus, this is 10, that is minus 10. Now we have got second equation also. Let us combine these both equations. Vb minus 20 is equals to 10d by 3. So this is my first equation. Let us add these both equations. This and this gets cancelled. Minus 20 is minus 40. And then minus, this is minus 10d. This is minus 10d. And so that would be 10d by 3 minus 10d. This would give me minus 40 is equals to 10d minus 30d by 3. This 3, if I multiply there, that would be minus 120 is equals to minus 20d. This and this gets cancelled, 2 1s to 6. So distance d is equals to 6 km. We have got the distance, that is 6 km. Now with this, we can find out velocity of the bus in substituting in any of the equation. Whichever equation you want, you can substitute. Velocity of bus minus 20 is equals to 10 into 6 by 3. 3 1s, 3 2s. So velocity of bus, we have got it as 40. So we got velocity of bus as 40. So once we got velocity of the bus, so velocity of the bus is equals to distance traveled by the bus by time. So velocity of the bus is 40. Distance traveled is equals to 6 divided by time. Time is equals to 40 by 6. And in the question he has asked, velocity into time. Velocity is 40 into, sorry, it is 6 by 40. I'm sorry here. Time is equals to 6 by 40. Time would be 6 by 40. And into 6 by 40, that both will be getting cancelled. You are going to get 6 is the answer for this question. So in both ways, even in relative velocity method or in normal ground related to the ground also, you can do this question. Whichever way you feel easy, you can do that question in that way. I hope you understood this. If you have any doubt, you can comment below. Thank you.